should be on. Cool. Okay. Once again, what were some of the transformations we talked about yesterday? Alex?
Reflection and translation.
Reflection and translation. So I'm going to write translation first. What is translation? If you were to describe that, what would it be? Okay, now.
Wait.
Alex?
The movement of like the position or like where an object's at, so like everything else stays exact same.
So you're taking an object and you're moving it. So I'm taking the square and I can move it around the board. But the square isn't changing at all. The square sides are staying the same. The square's angles are staying the same. All that's staying the same. The only thing that's changing about the square is where it's located. So that would be translation. Now once again, sorry, just to backtrack a little bit. Transformations. When we're talking about transformations, we're talking about taking an object, taking that pre-image, the image of what the object is before. I'm sorry. So the pre-image, once again, is that object before the transformation happens. So taking that pre-image and then doing some sort of change to that object and seeing what happens afterwards. Most of those changes will not change the object too much, but will really just change its orientation, its location. And so translation was our first transformation that we talked about, where we took it and we slid it around somewhere. What was the other one you said, Alex?
Reflection.
Reflection. So reflection is our second transformation. Survey. Reflection. Alright. How do we represent reflection? What does that look like for a transformation? You're flipping it. So we have a line with reflection. I'm going to square here. And we always flip over this line. So say this was my line of reflection. Our square would then be flipped over that line.
Wow.
Oh,
exactly.
Okay, so that square would be flipped over that line and land on the opposite side. Both of these distances, so this square to this line and this square to the line, they're both the same. It will always be equidistant from each other. The points should always be the same distance from the line. The squares should be the same. If I were an artist, they would be the same. But I'm a math teacher, so that's why. But all those angles, all those side lengths are exactly the same. Just as if you stand in a mirror, your reflection will always be the same as you. It's not changing anything about you. So translation and reflection. Okay. These were the two that we talked about yesterday. So we have two more. So there's four main transformations we're talking about in geometry. So translation, reflection are our first two, and we're going to cover the other two today as well. So our next one is going to be rotation. So rotation is when you take a pre-image, when you take that object, and it spins. You spin that pre-image about a point. So that point is always called our center of rotation, or you can just leave that center, because we know we're talking about rotation. So that center, you're going to spin about that certain point. The rotation doesn't change the object once again. So just like translation, reflection, your angles are staying the same, your side lengths are staying the same. All that's going to be the same. The only thing changing is how it's oriented. So I can take this triangle, and I can spin it about that center. So right now my center of rotation seems to be about right here. It's spinning about that point, rotating about that point. And when we rotate, I'm sorry? Yes, with rotation there will always be a center of rotation. Now sometimes when we get later on, when we start talking about the rules and how to graph these, I might give you a pre-image and I might give you the image afterwards and give you the rule and say, tell me where the center of rotation is, and you would have to find it based off your information. I'm sorry? If the circle was rotating?
Would it be in the circle or would it be around?
It can be either. So sometimes your center of rotation might be inside the object, sometimes your center of rotation might be outside the object, and it rotates around the object.
Would you ever have us, like, is there any way to solve for it?
Yeah, we'll talk about that next week, and where we'll actually start graphing them, and we'll actually start drawing these transformations ourselves. And you'll learn how to solve for a missing, or solve for like what the image would be, or solve for where that center would be, or how much it's rotated by. So we'll learn about that next week. But right now, we're just wanting to identify them. Just being able to see this image, see what's happening, and know, oh, that's rotation, that's translation. Just being able to recognize them. Um, so yeah, it's rotating about that point. We have 4 main amounts that we rotate by. When you're rotating, you're going about a circle. So what's the total angle measure of a circle again? 360. So as we rotate, we're traveling a certain number of degrees around that circle. And so the 4 main ones that we use are going to be our 4 quadrants or our 4 quarters of a circle. So the first one is 90 degrees. You rotate 90 degrees, you're only going a fourth of the way around the circle. Next we go 180 degrees. If we travel 180 degrees, you're going halfway around the circle.
Okay, so what is that?
I'm sorry.
Where only going like that? Or
So rather than rotating the whole way around the circle, the whole 360 degrees, sometimes rotation only travels a little bit. It's only rotating a little bit. Yes, yeah. So you should always know either that or it'll be like, given this pre-image in this image, how many degrees did this shape rotate? And so for this case, we rotate 90 degrees, 180 degrees. Next one will be 270 degrees.
So we always do is up by 90?
Mm-hmm. So 90 degrees is a quarter of your circle every time. And so those are the main rotations. It's possible to do a rotation of like 135 degrees or something, but that's harder to calculate. And so typically it'll be one of these 3, 4. Or one of these 4. One of these 4. And we have special rules that we'll talk about. So for 90 degrees, when you take a point, you switch the variable, you switch the x and the y, and you make one. We'll talk about those next week when we actually get to graphing. And sometimes you can eyeball these. Sometimes you won't have to use the rules. They're just there to help you. Yes.
on our skill quest tomorrow, are we like not solving things, or we just?
You're just identifying. So I will show you a picture of a transformation. I'll give you like the image and the pre-image in the image, and you have to say, oh, I think this is translation. What's happening in here is reflection. I'm sorry?
Like, earlier we said something like, create a post, we'll do that.
Mm-hmm. Yeah, so I'll have some examples later on in this of like what you might see. It really is just be you labeling which one you think it is. And so nothing.
It's out of 10.
Yeah, I think it's 10 points is what I made. I put it on progress book at the moment, and I haven't made it, but I know what the questions are. But yeah, I'll just show you an image, or I'll just show you 2 images, and you just have to say what transformation got the pre-image to the image.
Now, could rotation and translation get confusing, like, as the same thing?
So the way to help yourself memorize them, or to help you recognize what the difference is with translation. When you translate something, you're moving it around, but the orientation of the object is staying the same. My triangle is always staying upright this whole time. When I rotate my triangle, say I rotate about this center. As I rotate, my triangle is spinning, but also the side of my triangle that was facing my point should stay there as well. So as this triangle rotates about the circle, it should be spinning as well, if that makes sense. And so,
where the dot was.
yeah, where the dot was, that's my center that I'm using. And so it continues to spin back around. I don't know how I had it positioned at the beginning. Something like that.
Something rotate, almost like this. How do you do that?
It would be multiple transformations, which is possible. You can have multiple transformations back to back to back, which is possible. It wouldn't just be one transformation though. It would be one rotation, then a second, then another, and each of those would have a different center that you would rotate it. But the main thing to be able to help you recognize what's translation and what's rotation is the orientation of the object. So if it's translation, that triangle should stay that same upright position the whole time. If it's rotation, it's going to be the same oriented a little differently. So that was rotation. Next one we have is called dilation. So dilation is different from the other three transformations. We call those other three rigid motion transformations because no matter what, that triangle or that square or whatever I was rotating or whatever I was translating, it wasn't changing at all. The size was staying the same, the paint wasn't staying the same. Dilation is different from that one because dilation, you make it grow, you make it shrink. So you're increasing the image or decreasing the image. So the size is changing. Similarly to rotation though, dilation has a point you're changing about. So there will always be a point that you're dilating from. Sometimes there will be a point on the shape, sometimes there will be a point outside the shape. So in this example, my point of dilation is right here, I think. So this corner, I know it's hard to see, but that corner is staying the same. That point of dilation will always stay the same spot, while everything else around it will change by a given amount from that. And it'll be easier to see this when we start graphing it. For right now, with just having this shape and not having actual numbers, it's a little hard to recognize. But there will always be a specific amount. So sometimes you'll have a square, and you'll say, dilate this square about this point by 2. And so your factor, your ratio, will be you'll have to double the size. And so you'll take your square and you'll double the size. Or you might take it and you might cut it in half. So you might have your square, whatever it is, and you'll shrink it by half. Or you could shrink it by a third or something. And we'll practice with this next week when we start actually learning these rules. But just being able to recognize anytime you see a change in size, that's always going to be a dilation. You okay with this? Okay.
Would there ever be a point on the actual shape?
Yeah, sometimes. So if it is a point on the actual shape, that point will always stay the same, and it will so pretend this arrow isn't here. Pretend this blue square, this blue rectangle is what I'm dilating. As I dilate that blue rectangle, the rectangle is getting larger. That point is staying the same. The only thing that's changing are these side links. These side links are getting farther. So as this point stays the same, but these side links are increasing, this point is getting farther and farther away to the left. This point is getting farther and farther away down. As I shrink it, that point is getting closer and closer to my original corner. So depending, all your points on your shape will always change distance compared to that original center that you're dilating from. I wish I had a better example at the moment, but I don't. But we'll talk about that next week when we get there, when we actually start graphing. And I think you'll catch it pretty quickly. So I know we talked about this a little bit yesterday, but what are some examples? What are some examples in real life of transformations that you notice? Your pupils. So when you shine a light in your pupils, they grow or shrink based off of how much light they're trying to absorb. That's why your pupils dilate. Yes. So when you look in a mirror, you see a reflection. You're reflecting yourself. It's sort of flipped to the other side. What else? So the other ones were translation and rotation. What are you thinking, Alex?
Every time anyone or anything ever moves, it's translation.
So whenever something moves in a direction, that's translation. Anytime an object is moving, it's translated. What else? What about rotation? When do we see rotation?
Wheels.
Wheels. Anytime something is turning, a wheel is spinning, that's always rotation. It's doing a rotation about that axis. Your clock. So as the hands turn, they're rotating about the center of the clock. Good. Any other thoughts? So those are all good examples of transformations. So once again, transformations occur all the time. They're everywhere. It's just being able to recognize them. So what transformation do you see right here? From my pre-image to my image.
What's the one?
It's dilation. So I'm increasing in size. My pentagon is larger than before. So I'm dilating. Once again, these little apostrophes by all of those letters, those are the primes. So A was the pre-image. A prime is the image. So this is the point. It's the same point. It's just after the dilation has occurred. Yes. So every point will always have a representative point. Unless I'm like super lazy and didn't draw it. If I didn't draw it, then it's not. But if it's on there, then that's how you tell which point represents which point. Because if I didn't have these points, you might have thought for whatever reason it also got rotated and A was down here. But for this case, A is just going to represent A5. Those points should always help you be able to reorient yourself on what actually happened to the shape. Does that help clarify that? Okay. What about this one? What do you think happened here? Reflection. How do you think it got reflected?
No, rotation.
Rotation. So our rectangle got spun around, got rotated about their center, that's right about there, and got spun around 90 degrees up towards the top. And so I had a lot of students in the last class who thought this was reflection, because they thought if you have a line of reflection right here, then you see it's flipping around. But because the points don't match up, because B right here doesn't match with B prime, if this was B prime, then it would be a reflection. But because B prime is way over here, you need to know that obviously this was rotated up and not just reflected. So that's why those points come in handy. They always help us orient which side is actually the same side of my object. Okay, so this was rotation. And this would be a rotation by 90 degrees about, let's see, we're going clockwise. One important thing is it should always say whether it's clockwise or counterclockwise. If it doesn't say, always assume it's going to be counterclockwise. I know that's a little counterintuitive, but if it doesn't say clockwise, you can assume it's going to be counterclockwise. And we'll talk about that later on. But for now, that's all you need to recognize. All right, so I have multiple transformations happening right here. So I have my pre-image at 1, I have an image at 2, an image at 3, and an image at 4. So this was a 1 transformation from 1 to 2, then 2 to 3, 3 to 4. So what do you think would give you from 1 to 2? Reflection. So a transformation of a reflection can get you from there. We reflect over that line. 1 flips out and lands on the 2. Okay, so that can count as a reflection.
Oh,
The next one is rotation.
yeah. No, the next one is dilation.
The next one, we're dilating. We're increasing in size from 2 to 3. So we count that as a dilation. Good. What about from 3 to 4? Rotation. We're rotating counterclockwise 90 degrees up. And so we can move that rotation. And so once again, this is similar to what you might see. You're just given some transformation. You're told this is where you begin, this is where you end. What type of transformation will get you from A to B? Looking from 1 to 2, is there another answer you could give that? Is there another option? Rotation. How much are you rotating by?
180.
180 degrees. If you rotate 180 degrees, about a point right there, you're spinning all the way around and then flipping down to where it's at 2. So that top part of my trapezoid would now be the bottom. And so either a rotation of 180 degrees or a reflection can do that same transformation. So sometimes these transformations can be the same, or there could be multiple options that you could choose from. I know on the state test last year, I think it was one of the practice questions they had for the state test last year. They had a question of, they had an image and a pre-image, and they said what all combinations of transformations could get you from point A, or from my image to my pre-image, or my pre-image to my image. And so there's multiple correct answers. And so sometimes you might have to find all of the possible transformations to get you from A to B. Sometimes there might not be multiple answers, sometimes there might be. Sometimes you might need one transformation, could be the same as 2 transformations. And it really depends on how you go about making those transformations. And that'll be, once again, easier to see once we start actually graphing. But for right now, whenever I ask you something, I shouldn't give you an option of where there's more than one answer. Most of the time, all the things I'll give you should be one answer or two, or there should be only one answer. But if for whatever reason I made a mistake, you could either write one of them and I'll give you the correct answer, or you could write both of them and I'll give you the correct answer. If I do make a mistake, just let me know.
Right, so reflection always be rotation.
Almost always, yeah. If you're reflecting, it can almost always be a rotation of 180 degrees.
What
If
if it asks
it's horizontal or vertical. If it's diagonal, that gets a little trickier and it gets a little harder to rotate about that.
if it asks like what it is, would you go with?
I would accept either answer. If this was a problem, I would accept either rotation or
Would you
reflection.
go would you get the last point?
I wouldn't give you a bonus point, but I'd be proud of you. Maybe I'd go for grab or something. Maybe, I guess you weren't here last year. What's that?
Well, you like this one?
All right. I'm going to stop the recording there for now.
Way to go, Jarvis.
Does it sound?
Can you hear me?
Yeah, can it hear people?
We can hear you guys.